Hello guys, today we will learn about Beer's law, or it's also known as Lambert's Beer law. This is applicable to solutions. It means that when the light absorbing substance is present in a solution, there is decrease in intensity of light with the thickness of the solution. And the statement of the law goes like this: when a beam of monochromatic radiation is passed through a solution of an absorbing substance, the rate of decrease of intensity of radiation with the thickness of the absorbing solution is proportional to the intensity of incident radiation as well as to the concentration of the solution represented as C. So mathematically this can be represented as, this is the decrease negative, minus di by dx, where di represent the infinitesimally small decrease, the intensity of radiation, and where dx is the thickness of the medium, directly proportional to the intensity of radiation as well as to the concentration of the solution represented as C. So equating or removing the proportionality constant with a constant which is called as epsilon. It's a constant, it's called molar absorption coefficient, and its value depends upon the nature of the absorbing substance. C, the concentration of the solution is represented in moles per liter, as you know. Now integrating this first equation between the limits as in the previous law, I is equal to I0 to I and x is equal to 0 to x. Integral I0 to I di by I, just rearranging the equation, by k is equal to minus integral epsilon c dx, or taking the log to the base e, ln I by I0 is equal to minus ecx, second equation. Or we can raise it to the power of e, I by I0 is equal to e raised to minus epsilon cx, or I is equal to I0 e raised to minus epsilon cx. And this equation tells us how the original intensity I0 of the monochromatic light falls to intensity I on passing through a thickness x of the solution of concentration x. It's also clear that the intensity of light absorbed by the solution is given by the difference between I0 and I, as in the previous case. So the I absorbed will be the original intensity I0 minus the current intensity that's coming out, the intensity of the light coming out, I is equal to I0 minus, substituting the I with I0 e raised to minus epsilon cx and taking out I0, we'll get this expression. And also when you take the equation 2 in the previous step, taking log, substituting ln with the 2.303 log, you will get 2.303 log I by I0 is equal to minus epsilon cx. So log I by I0 is equal to minus 1 by 2.303 epsilon cx. Log I by I0 is equal to minus epsilon dash, that is epsilon by 2.303, epsilon by 2.303 is taken as epsilon dash, which is known as the molar extinction coefficient of the absorbing medium, or I by I0 is equal to 10 raised to minus epsilon dash cx when we are raising it to the power 10. And what is the physical significance of this molar extinction coefficient? Let's see. Let's take this equation. Log I by I0 is equal to minus epsilon dash cx. Rearranging, epsilon dash will be equal to minus 1 by cx log I by I0. And when this term log I by I0 is taken as 1, then epsilon dash will be equal to this minus 1 by cx. And when C is equal to 1 molar, here C is equal to 1 molar, then epsilon dash will be equal to 1 by x. So when do this log I0 by I term becomes 1? Then I0 by I will become 10. So I is equal to 1 by 10 of I0. That means when the light intensity reduces to the 1 by 10th of its original intensity, then we can define molar extinction coefficient as the reciprocal of that thickness of the solution layer of 1 molar concentration, which reduces the intensity of light passing through it to 1 by 10th of its original value. So, this term log I0 by I can be called as absorbance. And also, on combining the two laws, Beer-Lambert's law can be formulated as log I0 by I is equal to epsilon C into L, which is known as the absorbance. So this is the absorbance. So absorbance is equal to epsilon into C into L, where C is the concentration of the solution in moles per liter. L is the path length of the solution. Usually it is 1 centimeter. And epsilon is the molar extinction coefficient or the molar absorptivity. A is known as the absorbance. A is the absorbance. There is another representation. Absorbance is equal to minus log transmittance. We'll see it later. So with the limitations of the Beer-Lambert's law, we'll stop. When different forms of the absorbing molecules are in equilibrium, as in keto-enol tautomers, this law is not obeyed. And also, when fluorescent compounds are present, the law is not obeyed. When solute and solvent form complexes through some sort of associations, then also this law is not applicable. Thank you so much for your patient listening.